Okay, so now let's look at one example like this. So it's integral from 0 to pi over 4 dx over 1 minus sine x. Okay. So apparently you can see that if we use the substitution, it will not work, because if you set your u equals, let's see, 1 minus sine of x, we only have one choice, and then du is going to be negative cosine x dx. And as you can see, it's impossible for us to substitute this part into du. Okay, so u substitution, it does not work. So for solving this problem, we're going to introduce a technique. It's called the conjugate. Okay, conjugate. And you know, the purpose of the conjugate, it's when you multiply a pairs of conjugates, it will form the difference of squares. Okay. For example, if you have a minus b, and the corresponding conjugate are going to be a plus b, right? So if you multiply them, you're going to have a squared minus b squared. Okay. And okay, so that's the central idea. Why we want to use a conjugate? Because we know this: sine squared plus cosine squared equals 1, right? And then cosine squared x equals 1 minus sine squared. You see, we have 1 minus sine x, and if we have 1 minus sine squared, and then we can actually rewrite the equivalent formula, which is cosine squared. Okay, that will help us to simplify this. Okay, so let's do that. So I multiply the conjugate over itself, so 0 to pi over 4, and 1 over 1 minus sine x times 1 plus sine x over 1 plus sine x, and then dx. Okay, so this is conjugate over the conjugate, so it's a 1, so I did not change my problem. And if you simplify it, you will see this is what you get. On the top, it's 1 plus sine x. On the bottom, it's 1 minus sine squared dx. As we just discussed, we're going to use this trig identity to change our denominator into cosine squared x, 1 plus sine x dx. Okay. And then up to here, things looks much better, because we can do 1 over cosine squared x plus dx integral 0 to pi over 4 sine x over cosine squared x dx. Okay. And 1 over cosine squared is actually secant squared. And then for here, sine over cosine squared x actually can be written as sine over cosine x times 1 over cosine x, which is going to be tan x times secant x, and then dx. Okay, so a little bit explanation to here. Sine x over cosine squared x can be written into sine x over cosine x times 1 over cosine x. That is tan x times secant x. That's how we get here. Okay, so that's the explanation. Now, it turns out the antiderivative of the secant is tan x. Okay, the antiderivative of tan x secant x is, well, secant x. Okay, and then divided from 0 to pi over 4. Turns out tan pi over 4 plus secant pi over 4 minus tan 0 plus secant 0. This is 1. This is going to be square root of 2. This is 0. This is going to be secant 0 is 1. And the final answer for this is going to be square root of 2. Okay? So that is a simple example using the idea of conjugate. Hope you enjoy this video.